today we are going to start with memory, storage device and data representation. So first is memory. So we already know that computer has two types of memory. That is, the first one is primary memory. It is called main memory, and most common primary memory is RAM. And second is secondary memory. It is also called auxiliary memory. And in this category, the most common example is hard disk. So on any of this type, that is primary and secondary, whatever information is stored, that is in digital form. And digital form in computer means 0 and 1. So everything is stored in zeros and 1 here. Now we are going to discuss about different units of memory. So the smallest is 1 bit. 0 and 1, again I am going to tell you, 0 and 1 is what? Binary digits. And here in computer terms, 0 represent when the current is off, and 1 is when current is passing, that is current is flowing, that is 1. So in any of these two states, the information is passed on off signals. So bit is full form of bit is here binary digit. So here when we call it bit, 1 bit, that is one binary digit. Now here different units are there. Like in metric system, you are having meter, kilometer, like that. Here we are having KB, MB, GB, TB, like that. So here is one table wherein we are starting from the smallest unit, that is 1 bit. Below this there is one more unit, that is nibble, NIBBLE. So 1 bit is equal to a single digit. It can store either 0 or 1 only. Then group of 8 bit, that is 1 byte. Okay, 1 byte is composed of 8 single bits. So in these 8 different units, we can use combination of zeros and ones to represent a number. For example, I am showing you here one example. So here I have prepared 8 locations. Okay, these are 8 locations. So first one is 1, 2, 3, 4, 5, 6, 7 and 8. You can consider it as 1 bit. So this 1 bit 8 times makes 1 byte. So here you can have different values like ones and zeros. So these are representation of 1 byte of storage, and some number is stored here. Okay, now you can see here it is 10101010. Okay, this is one binary number. So the value, decimal value of the first is 1, second is double 2, third is 4. How it comes, that we will see afterwards. So I am going to show you which number we have represented here. Okay, so decimal equivalent to this one is 128, because after this one there are 7 more digits. Okay, so here it is 128 if it is 1. So now we have to multiply this both 1 and 128. For example, like this is multiplication. Okay, and here value, that is 128. Same way here also, everywhere we are going to multiply. So here 0 multiplied by 64, that will become 0 only. Here 32 multiplied by 1 is 32. Here 16 multiplied by 0 is 0. Here 8 multiplied by 1 is 8. 0 multiplied by 4 is 0 again. And 1 multiplied by 2 is 2 here. And here 0 multiplied by 1 is 0. Okay. So here if we make total decimal equivalent to this number, this one, is 170. So to represent 170 decimal number in binary form, we can use 1 byte memory storage, and we have to write like this: 10101010, that is 170. Okay, so this is 1 bit, only single digit we can store here like this. This is 1 bit only, it is having one single digit, that is 1. This is another next bit, it is having 0. So only in 1 bit we can store a single number out of 2, that is 1 and 0. Then 8 bits, that is 1 byte. Okay, here we have seen one example. In 1 byte we have used combination of zeros and ones to represent a number. Then here 2 raised to power of 10 bytes is equal to 1024 bytes, that is 1 KB, kilobyte. Okay, so in normal life we have 1000 grams is equal to 1 kilogram, but here it is 1024. Okay, so why it is 1024? Because this is formula: 2 raised to power of 10, then 20, then 30 and 40. So it is not rounded off, that is 1000 1000 1000 is 1024, but it is the nearest value to 1000, that's why we are taking it as 1 kilobyte. Same way, when 2 raised to power of 20 bytes are there, it is 1 MB. Then 2 raised to power of 30 is 1 GB, that is gigabyte. Then terabyte, that is 1024 gigabytes. Primary memory, we call it main memory, because whenever we are doing something, the first place where data is stored is in primary memory until we save it in secondary memory. And whatever processes are going inside your computer in background, that also have their data in primary memory. Now for example, I am showing you, right now we have this Google Chrome open, one Adobe Reader open. Here 4 folders I have opened, one notepad is there, Telegram is there, and Excel is there. So from user there are few processes only that are started, these many applications, but actually there are, you can see here, list of processes that are on. So these are apps that I have started. Okay, and how much memory it is occupying, that also you can see here. Here background processes are there which runs automatically, that also occupy memory, that is primary memory. So this much primary memory is used in other applications or processes that I am not using, but when we start our computer, it runs automatically in background. So these many services are there. These are window processes. Okay, so this everything is there in our primary memory. Here you can see that it is occupying 24%, 20% CPU, and memory that it is using is 83% of my computer's capacity. So this way, primary memory is responsible to hold values of, hold storage data of the processes or application that are running on computer. Now, how this primary memory read data? Because at a time I am doing many things, like this is one file I have opened, then I am going into this Google Chrome, then I am opening this Excel. So when there are many processes, process requests, at that time there is one rule, that is FIFO, that is first in first out. Whatever process is started first, output for that process will be generated first. And there is another concept that is last in first out. So whatever process I have requested at last, that will be executed at first. So there are examples. In sequential access memory, data is stored serially or sequentially in a long string like this. For example, you can consider this as sequential data. In continuous storage, it is occupying continuous storage, okay, without leaving space between. That is sequential data. Now, when you want to access some part of the string, you have to pass through the previous part of the string. For example, if I want computer to read only this much part of data at that time, since this start from here, computer is going to pass through here, okay, to get these values. So that is previous part of the string. Just like an audio tape, if you want to hear the third song, first two song must be fast forwarded. Okay, it will start from the beginning itself, and you are supposed to forward the part that you do not want to hear. FIFO is just like queue. First in, first out means whatever request, first request you have sent, that will be on the top and the last request will be on the bottom. Okay, it is like a queue where first entry will be served first and last will be entertained at last. That is process last. In LIFO, that is last in, first out. It is like when you are putting papers one above another. So the last that you put will be on the top. Okay. So that is like this. The last request will be processed first, LIFO, LIFO. So here one picture is there. Here you can see this. This is in, then processes. So you can see that the first was this blue, second was orange, and here it is green. So in same sequence, it goes into process, and in output, the same sequence is there: green, blue, orange, and green. This is first in, first out. So these three things you can consider as processes. Now in last in, first out, this sequence will get reversed. Okay, this is first, second, third. Here first, second, and third. Now here in output it is reversed. That is 3, 2, and 1. Okay, like that. This is a RAM chip. You can see this if you open your CPU box. It is not advisable to use to open the box. It is there inside your CPU box and it looks like this. This is RAM chip, random access memory. This memory is used for the purpose of background services and running applications storage that we have just seen. Now there are different type of RAM. One is DRAM, that is dynamic RAM, and the second is static RAM, that is SRAM. So dynamic RAM needs to be refreshed thousands of times per second. That is dynamic RAM. Means why it gets refreshed, because if I close an application or process, so that much amount of memory will get cleared when this RAM is refreshed. Okay, so that we have more space for a new application to start. And static RAM does not need to be refreshed, which makes it faster. So static RAM do this process automatically. That is why it is faster. Because if we forget to do that, removing that memory or to make it clear, it is done automatically. Now since both this SRAM and DRAM are primary memory, we know that the nature of primary memory is volatile. That means when we turn off computer, whatever is stored inside this RAM is cleared. We can't get it back when we turn on computer again. Now computer also have ROM, that is read-only memory. Read-only memory means where data is stored only once. That is read-only memory. You cannot write on it. Here content of ROM can be read. Unlike RAM, ROM retains its content even when the computer is turned off. So we know that RAM is cleared each time we turn off our computer, but ROM will hold the data since it is read-only memory. It is not supposed to be written again. So ROM holds that data even after we turn off our computer. Why ROM is required? It is an ideal memory to store critical instruction into the computer such as boot programs. Boot programs are the programs that require when computer is started. The first instruction that computer require when we start our computer, that is boot program. This type of instructions are stored in ROM. Then PROMs are there, that is programmable read only memory. So earlier only ROM is read only memory, but here PROM is programmable read only memory, wherein blank chips are there which can be written with special device called PROM programmer, that is programmable read only memory programmer. And there is EPROM, that is erasable programmable read only memory, wherein we can erase earlier data from this ROM and we can write new data, erasable and programmable. And then comes EEPROM, that is erasable, electrically erasable programmable read only memory, where you can erase data electrically and then you can write data on it. Now EEPROMs are very useful in manufacturing USB pen drives, cellular phones memory, digital cameras, digital camera cards are there, portable MP3 players, and micro SD cards. In this type of memory are erasable and again writable. You can write data on it again. Examples are there. This is micro SD card. We use it in mobile phones. Here, this device is card reader. From this end, we plug it into our computer, and here different slots are there. One is for micro SD and another is for SD. Okay, SD is a bigger card than micro SD card, and usually this type of SD cards are used in digital cameras for storing images and videos. Now this ROM, that is read only memory, is used by manufacturer, wherein instruction is to be written only once. Like we have discussed already this example of oven and washing machine. So ROMs are there, read only memories. Whatever is written, that instruction from manufacturer, we are using it till lifetime of that product. The same instruction works for longer time. Now about firmware, there is something we have to know more, that is firmware are developed by the hardware manufacturing company and provided free with one purchase. One purchases the hardware. When we purchase the hardware, it comes automatically with that hardware. Another alternative is to download such firmware from company's online store or website. If it is not there, for example, if we have purchased a device and we want to have new version of software of that product, at that time that software is available in online store or on website of that company, we can download it and install it in our device. And this type of firmware is called firmware over the air, that is FOTA. It is also called mobile firmware, which makes the activity independent of cables, computer, and third-party software. So example of this type of software is system software of your cell phone. Whenever a new update is available, you get a notification to install. So you can update your cell phone software also. Now there is a special high-speed storage mechanism called cache. Cache memory is small and high-speed memory within the computer's central processing unit for frequent access. This type of memory is inside your CPU, and it helps to increase the speed of computer processor. When the processor needs to perform any read-write operation, it first checks the cache memory. Okay, so this type of memory is faster than RAM or ROM. Now there is difference between RAM and ROM, that is random access memory and read-only memory. So first one is RAM is random access memory, full form. ROM is read-only memory. Then RAM support reading and writing operations into the computer. Both operation read and write can be done on RAM, where, whereas on ROM have you can do only read option. Now data and instruction are stored in it during its operation. Whenever you are doing something at that time only, data and instructions are stored in RAM. And in ROM, whatever data is there on ROM is written during manufacturing time. RAM, it is volatile memory. We lost the data when we turn off our computer. And in ROM, it is non-volatile memory. It is permanent memory.